In this slide, we'll discuss the factors on which upthrust depends. First of all, if we observe the formula for upthrust, it is the most refined form of the formula is the formula that is more applicable is it is density of the liquid into acceleration due to gravity into volume of the object that is immersed. It will be a wrong practice to write the volume of the object. It's better to write volume immersed. Now some questions about this upthrust. For example, you have a situation where you have a liquid in which you have a ball made of wood and a ball made of steel. This is ball A and this is ball B. A steel ball and a copper ball have same volume and both are immersed in a liquid which will they both are fully immersed in the liquid. Which of them will experience more upthrust? Which of the two balls will experience more upthrust? So this is the question. An answer to this question is, oh, I have written spellings of steel wrong accidentally. So the second ball is made of steel. Now here, most of the students start thinking, they confuse this density of the liquid with the density of the object. If we compare all the factors, they both are in same liquid, G is same for both of them, and volume immersed is also same. So interestingly, they both will experience same upthrust if their volume is same, because one thing of the object that matters is the volume of the object and nothing else. So we should write upthrust. We need to write that upthrust does not depend on the density of the object. The only difference between these two objects is their density. Upthrust is independent of the density of upthrust is independent of the density of the object. It only depends on the volume of the object, and taking acceleration due to gravity constant, the two other factors are volume of the object and density of the liquid. So these are the two factors on which the upthrust depends. So both the balls will experience same upthrust because they have same volume and they are fully immersed. They are fully immersed in the same liquid. So they will experience same upthrust. Here we have another question. We get a situation where We have two cuboid objects. One is in this vertical position and the second is in this one of them is in the vertical position while the second one is in the horizontal position as shown. Now these are the two objects. One of them is in the vertical position and the second is in horizontal position, yet their dimensions are same. This side is 5 centimeter, this side is 4 centimeter, and this side is, let's suppose, 1 centimeter. For this object, this side is 5 centimeter, this side is 1 centimeter, and this side is 4 centimeter. So since the dimensions are same, they have same volume. This one is A and this one is B. However, A is vertical and B is horizontal. Now this is the liquid in which they both are fully immersed. What is comparison of compare upthrust on A and on B? Compare upthrust on A and upthrust on B. The answer to this question would be they will experience same upthrust as density of liquid. They both are in same liquid, is same for both. Smaller g is a constant and the immersed volume for both of them is 1 centimeter into 4 centimeter into 5 centimeter. All the three factors on which upthrust depends is same for both the objects. So upthrust on A will be equal to upthrust on B. Both of them will experience same upthrust. So we cannot say that the upthrust is different. The upthrust is same for both of them. So what is the orientation in liquid or how they are immersed in the liquid is not important. The important thing is how much of their volume is immersed in the liquid. So you see the volume immersed in the liquid is same. So they both will experience same upthrust since they are in the same liquid. So this is the main concept here. Now another example is, let's take a wooden ball and immerse it in the liquid and then take that ball towards the depth. For example, we have this container of liquid. In this container of liquid, we have a ball here. A ball is here and it is taken towards depth. It is taken towards depth. Now, in this question, we have two parts. A ball is fully immersed in a liquid and is taken towards the depth. Now the question is that the A part of the question, if this ball is taken towards the depth, generally students start thinking that when the ball will go towards the depth, the upthrust will go on to increase. It's a wrong answer. First of all, the question is that what will be the effect on upthrust? It's better to think about the upthrust using the formula. So what is the effect on the upthrust? It's better to think about the upthrust by observing the formula. You see, the formula for upthrust is density of the liquid into acceleration due to gravity into volume immersed. Now just think about this situation. If you're taking this ball towards the depth, the density of the liquid, assuming it to be a uniform liquid, will remain same. Smaller g is a constant, and once the object is fully immersed, the immersed volume will not change. Upthrust does not depend on the depth, but on the immersed volume. So during this, there is no change of density of liquid. If the liquid is uniform, it is unchanged. Smaller g, it is taken to be constant. The immersed volume, once the object is fully immersed, it will remain constant. So even if the object is taken towards the depth, the immersed volume, once the object is fully immersed, it will remain constant. The upthrust will not increase or decrease if an already fully immersed if a fully immersed object is taken towards the depth. So if a fully immersed object is taken towards the depth, the upthrust will not change. The upthrust does not depend on the depth, but it depends on the immersed volume. Once the object is fully immersed, increasing the depth will not increase its immersed volume. The second part of this question is about what will be the effect on the pressure, that is the deforming object effect basically. What will be the effect on the pressure on the object as it is moved towards the depth. Now let us explain this in a further detail. That is, first the effect on upthrust and then the effect on pressure should be explained in a further detail. You see, the problem here is, for example, if pressure here was 10 Pascal and pressure here was 30 Pascal, and pressure from the two sides, let's suppose it was 20 pascals. Now, because of the equal pressures on the sides and forces in the opposite direction, this pressure is cancelled out. And here the delta P that we are getting vertically upwards is 30 minus 10, that is 20 Pascal. One important thing is when you take this object towards the depth, then for example, if the pressure on the top becomes 40 Pascal, then pressure on the bottom will become 60 Pascal. One thing is worth observing, that is, one thing that you must observe is that if you look carefully, then if you look, let me check my pencil. I think its charging is over. Yes, the charging of the pencil is over. From here on, I will start in the next slide. Let me charge the pencil first. Take care, students. Khuda Hafiz.